Hello students, a warm welcome to all of you. Today in this module, we are going to discuss really something which is very much useful for every single student who is going to appear 10th class CBSE board examinations. You know why? I am being a mathematics teacher over about 15 years of teaching experience in CBSE curriculum. I would like to give you a wonderful content for every single student who can score easily above 80 percentage. See here, some of you are really scared of mathematics because of this revised CCE pattern and because of this pandemic situation, because of all on these online classes are happening. I think you must be really worried about your board examinations. But I will give you tips in order to get above 80 percentage marks easily. Above 80 percentage, you just follow my videos and just go through every single problem. I will give you what are all the questions given in previous CBSE board examinations for 1 mark and for 2 marks and for 3 marks as well as 4 marks. Now according to revised pattern, there will be 1 mark, 2 markers, 3 markers as well as 5 markers. So 1 markers are named as very short answer questions and 2 markers are short answer questions. 3 markers are long answer questions as well as 5 markers are essay answer questions. You definitely feel pretty much comfortable while listening to these videos, and you can definitely understand because I will give you explanation for every single problem that I am going to explain on the board. So please do concentrate, concentrate. Right? Shall we start? Out of all these 15 chapters in our grade 10 CBSE curriculum, I will go one by one chapter. The very first chapter is our real numbers. So in this concept of real numbers, we have some subtopics. Those subtopics are the very first topic is Euclid's division algorithm or Euclid's division lemma. And the second one is finding LCM and HCF of two numbers and the relationship between LCM and HCF of two numbers. And then some applications basing on LCM and HCF of numbers, right? And then immediately we have irrational numbers. How to prove one particular number as an irrational number. And then we have some rational numbers which are in the form of P by Q, in which conditions we can express them as terminating decimal, in which condition we can express them are non-terminating decimals. So like that, we have totally 4 exercises in our first chapter real numbers. Now I am going through all the topics together because every single topic depending on the other, and they are all very much simple concepts. And then I will give you few set of problems on the board and I will explain. So please do concentrate. Yes, let us start with the problems given in previous board examinations, and starting with very short answer type questions. It means carries 1 mark. Here the problem is a number n when divided by 16 gives the remainder 5. A number n when divided by 16 gives the remainder 5. Let us try to write this in division format. So what is the division format? You are dividing number n. Okay. Number n is divided by 16. Then we do not know what is the quotient. Let the quotient be some q1. Then the remainder is going to be 5. So remainder is going to be 5. Then if I write it in division rule, that is dividend equal to divisor into quotient plus remainder, then you can write it as dividend is n equal to divisor into quotient plus remainder. The remainder is going to be 5. That is what is the information given. Now, what is the remainder? What is the remainder when the same number is divided by 8? What is the same number? N is the same number. So, what is the remainder when the same number is divided by 8? I do not know what is the quotient. let the quotient is equal to Q2, and we do not know what is the remainder also. The remainder is equal to R, but R is equal to how much? I am going to write this in the same standard form, that is N is equal to 8 into Q2 plus remainder R. So how do I get the remainder here when the same number N is divided by the 8? See, the answer is there itself. You know how? I am going to write this N is equal to 16 into Q plus 5. 16 into Q plus 5. Since 16 is a multiple of 8, I am going to write this as 8 into 2Q plus 5. Right? 8 into something plus 5. 8 into something plus 5. So that I am going to write this one as N is equal to 8 into this something. Can I write that something as quotient? That quotient is Q2 plus 5. Now you see, your answer is there itself. What is that? N is equal to 8 into Q2 plus 5. N is equal to 8 into Q2 plus R. Then what is the value of the remainder R? Remainder R is going to be 5. So therefore, when the same number N is divided by 8, the remainder remains unchanged, because 16 is a multiple of 8. Hope you understand how easily we can answer the problem, right? Shall we move on to the next problem? Okay, fine. So the next problem is going to be, what is the HCF of 3 power 3 into 5 power 4 and 3 power 4 into 5 square? What do you mean by HCF? Highest common factor. So highest common factor means you will have to figure out all the factors, list out all the factors of both the numbers, and you see what is the highest common factor, right? I'm going to take the first number. Let me take the first number. For example, first number is A. That A is going to be 3 power 3 into 5 to the power of 4. This is the first number. And the second number B is going to be 3 to the power of 4 into 5 to the power of 2. Okay. Suppose when you are given two numbers, for example, those two numbers are like 9 comma some 36 is there. 9 comma 36. How do you find HCF of those two numbers? We will start doing L method. That is, you see both the numbers and what is the common factor. If you can identify what is the highest one, you can do it. Suppose I do not know, then I will see 9 and 36 both are divisible by 3. Yes. So 3 3s are 9 and 3 12s are 36. But still 3 and 12 can be divisible by 3. So that I will go by 3 again. So 3 1s are 3, 3 4s are 12. Now 1 comma 4 are divisible by only 1. It means for 1 and 4 there is only one common factor, that is 1. But till here we got two common factors. What is the product of these two common factors? 3 into 3 is equal to 9. So it means 9 is the HCF of these two numbers. As simple as that. Now coming to the HCF of these two numbers. Okay. See here 3 power 3 and 3 power 4. Is 3 power 3 bigger than 3 power 4 or 3 power 4 bigger than 3 power 3? 3 power 4 bigger than 3 power 3. So I would like to write 3 power 4 as 3 power 3 into 3 into 5 power 2 and 5 power 4. So here 5 power 2 is smaller than 5 power 4. So write 5 power 2 like that. And going to modify this. 3 power 3, 3 power 3. So I am not writing 3 power 4 again or 3 power 3. I am not going to split it. And 5 power 4 is bigger than 5 power 2. That is why I am going to write 5 power 4 as 5 power 2 into 5 power 2. Got my point? Now see what are the common things in both. See 3 power 3, 3 power 3. 3 power 3 is the common one in both. And 5 power 2, 5 power 2. So 5 power 2 is also common one in both. And here 5 power 2 extra, there is no 5 power 2. 3 is extra, there is no 3. So therefore, highest common factor of A and B is going to be 3 power 3, 3 power 3. So 3 power 3 into 5 power 2, 5 power 2, 5 power 2. Right? So 3 power 3 into 5 power 2 is the HCF of the given two numbers. Hope you understand how to answer this. Right. So moving on to the next problem. Here it is. If a is equal to xy square and b is equal to x cube into y to the power of 5, where x and y are prime numbers, then what is the LCM of a comma b? See, we know how to find LCM of numbers. Do you know how to find LCM of variables? Is same as like numbers. Just observe what I am going to do. See here, the two numbers are, I am going to write the given numbers. A is equal to xy square. So can I write y square as y into y? Correct? So x is equal x into y, that is a. And what about b? B is equal to x cube. X cube means what? X times x into y to the power of 5 is going to be y into y into y into y into y. Right? Sir, you are writing y power 5 as y into y into y into y. If it is y power 2000, will you write y into y and so on up to 2000 times? No, I am not going to write. Just I am explaining you for you to understand in the easiest way. Right? Now, going to find what is the LCM of these two numbers. Okay? Writing both the numbers together, like how you write the numbers, x into y into y, x into y into y. This is the first number. And the second number is x into x into x. Again, y is 5 times, right? So y into y into y into y into y. Got it? So there are 5 y's. Now, same as like our L method. Here you have 1x, here you have 1x. Since x is the common factor, right? I am going to write that. X, how much are x into y into y? X, y into y's are. And similarly here, x, 1x already there, remaining 2 x's are there, into y, anyway we are not using, y into y into y into y into y. Right? Because x is only the number. Now, y into y is there. Okay? Here y into y, here there are so many y's. So that I am going to write y into y. Y into y into how many number of times is y into y? Again only one time, because we used it. And x into x we did not use, so x into x into, we have taken already 2 y's, then remaining 3 y's are there, so y into y into y. Right? Again, is there any common factor for these two except 1? No, because it is only 1. Therefore, what is LCM of A and B? LCM of A and B is going to be, how do you find LCM? You start multiplying right from the top. Okay, here it is x into, here y into y, can I write it as y square, into, here it is 1, I will write that 1 also, into x into x is equal to x square, into y into y into y is equal to y cube. So finally what are you getting? You are getting here x into x square is equal to x cube, into y square into y cube is equal to y to the power of 5. So x cube into y to the power of 5 is the LCM of these two numbers. This is what is the general method in order to find what is the LCM of the given numbers. Now I will explain you how to answer this problem directly instead of doing all these things. But you will have to observe all these things in order to get a better idea in finding LCM of two numbers involving variables. Right? Shall we try with another way? That another way is going to be, see, I have two numbers. One number is xy square. What is another number? X cube into y to the power of 5. These two are two numbers. Okay. Same. In both, let us say x terms first of all. Here we have only one x. Here x is x cube. So x is only the common factor. So x, how much are xy square? Xy squares are xy square. X, how much are x cube? X squares are x cube. And y power 5 is already there. So y to the power of 5. Clear? Again, both of them are divisible by, here y power 2 and y power 5. So y power 2 is the maximum one. So that I am going to write y square. Y square ones are y square. And y square, x square is already there. Y square into how much equal to y power 5? Y square into y cube is equal to y power 5. Got it? Now see, this is 1. you cannot find again. Therefore, what is the LCM of those two numbers? LCM of A and B is going to be, again, start multiplying. Here it is x, and here it is y square, and here it is x square, and y to the power of 3. So finally, x into x square equal to x cube, y square into y cube equal to y to the power of 5. This way, easily, without listing out all the factors, we can find LCM of two numbers. I would like to tell you one more thing. Suppose if you are asked what is the HCF of those two numbers, can you tell me what is the HCF of those two numbers? See, till here you have common factors. From here onwards, there is no common factor. Then HCF of these two numbers is going to be xy square. I am giving you extra information. That is what HCF of A and B is going to be xy square. Xy square is the HCF. Of course, xy square is going to be small a. So this is what is the HCF of the given two numbers. Hope you understand? Yes. Let's moving on to next problem. Here the next problem is quite interesting. If n is always a natural number, then 25 to the power of 2n minus 9 to the power of 2n is always divisible by which of the numbers? Let me write the given number here, that is 25 to the power of 2n minus 9 to the power of 2n. Okay, 25 to the power of 2n minus 9 to the power of 2n. Will you be able to simplify it more? Just see if it is possible. Will you be able to simplify it more? And if you simplify it more, then it will be in which form? Which form I am talking about? See, 2n and 2n. 2n is nothing but 2 multiplied by n. Can I write this 25 to the power of 2n as 25 to the power of 2 whole to the power of n? Because it is already in the form of a to the power of m into n. A to the power of m into n equal to a power m whole to the power of n. So that is why I am writing it as 25 to the power of 2 whole to the power of n. Similarly, I can write this as 9 to the power of 2 whole to the power of n. What is the value of 25 square? Is going to be 625 to the power of n minus 9 square is equal to 81 to the power of n. Now this is in which form? X power n minus y power n. What is the formula for x to the power of n minus y to the power of n? We do not know. For example, then let us start with n equal to 1, n equal to 2, n equal to 3. For example, if n is equal to 1, then it is going to be x power 1 minus y power 1. If n is equal to 2, then it is going to be x square minus y square. So, x power 1 minus y power 1 means x minus y. And here x square minus y square is going to be x minus y times x plus y. And if you write n is equal to 3, then it is x cube minus y cube is equal to x minus y times x square plus xy plus y square. So like that, you can write expansions easily. But if you once observe in all these expansions of x power n minus y power n, the very first common factor is x minus y. And then you will have one more term. So it means x minus y is the common factor for every expression which is in the form of x power n minus y power n. Hope you understand. Now this is also in the form of x power n minus y power n. Can you write this one as x minus y? It means 625 minus 81 into something. What is that something? That is the second factor. That depends on the value of n. Got it? So 625 minus 81 is equal to how much? 5 minus 1 equal to 4. 12 minus 8 is equal to 4. And I think it is 554. 544. What are the factors of 544? I am going to write the factors. So it is divisible by 2 because last number is even number. So 2 2s are 4, 2 7s are 14, again 2 2s are 4. Next, again multiplying by 2. 2 into, so 2 1s are 2, 2 3s are 6, 2 6 are 12. I think 36 is divisible by 4, right? Okay. So 2 into 2 into 4 into 4 3s are 12, 16, 4 4s are 16. So now finally what we got, 2 into 2 equal to 4 into 4 is equal to 16 multiplied by 34. I stopped there. You know why? According to the given problem, we have the numbers 16 and 34. Of course, 34 can be written as again 2 into 17. But here 16 and 34 both are the factors of 25 to the power of 2n minus 9 to the power of 2n. So which is the correct option according to this? Is 16 correct option or is 34 correct option? Are both 16 or 34 correct option? 13 or 64, 13 and 64 actually. It should be given 13 and 64. So according to this, our option is going to be both 16 and 34. Because 16 is a factor, 34 is also the factor. So please do remember, this kind of problems can be solved easily, but you will have to remember x power n minus y power n expansion. For every x power n minus y power n, x minus y is the common factor. The second thing can be depending upon the value of n, right? You see, like that. Hope you understand. Moving on to the next problem. Here the next problem is in the factor tree. I think you learned this factor tree even in 6th class, 7th class, right? It's pretty much easier for you. Even without my help, you can answer the problem. So these are all the factors. Always factors start from the top, isn't it? See, for example, I have a number like 12. For example, my number is 12. So now I am going to factorize this 12 as 2 into 6 is equal to 12. Again, I am going to write this 6. 6 can be factorized, right? 6 can be factorized as 2 into 3. So 2 times 3 is equal to 6. This is what is called factor tree of which number? Factor tree of the number 12. If you observe this closely, 6 can be written as 2 into 3. It means 2 into 3 is equal to 6, right? As simple as that. Again, 2 into 6 is equal to 12. It means start from the bottom, multiply the numbers right from the bottom and go up. That's it. See here, 5 sevens are how much? 5 into 7 is equal to 35. So x is going to be 35. Right? So 2 into 35 is equal to how much? 2 into 35 is equal to 70. Is it not simple? Pretty much easier. So moving on to the next problem. P to the power of n is equal to a into 5 whole to the power of n. So given that P to the power of n is equal to a into 5 whole to the power of n, and this number means P to the power of n and with the digit 0. And with the digit 0. We have some problems in even second exercise, third exercise. For what value of n 4 to the power of n ends with the digit 0? Or for what value of n 6 to the power of n ends with the digit 0? See, if you write n is equal to any natural number, 4 power n, neither 4 power n nor 6 power n ends with 0. You know why? 4 power 1 equal to 4. 4 square equal to 16 means ends with 6. 4 cube equal to 64 again ends with 4. So it means 4 to the power of n always ends with either 4 or 6. It never ends with the digit 0. Similarly 6 to the power of n equal to 1. 6 to the power of 1 equal to 6. 6 square equal to 36 again it is ending with 6. 6 cube is equal to again 216 again it ends with the digit 6. It means 6 to the power of n will never end with the digit 0. Then what kind of numbers ends with the digit 0? If the base of the number ends with the digit 0, then only the total number ends with the digit 0. Otherwise, it will never end with the digit 0. Then when the base of the number ends with the digit 0, see for example, you have any number like 30 to the power of n. 30 to the power of n always ends with the digit 0. Because in this base, of course, you have 0, but you can write this 30 as 3 into 10. Again, you can write this as 3 into 2 into 5. And for example, if you take one number like 20 power n, you can write this 20 as 2 into 10 whole to the power of n. Again, you can write it as 2 into 2 into 5 whole to the power of n. This number always ends with the digit 0. This number also always ends with the digit 0. Then if you see the prime factorization of the number which is in the place of base, see here and here, 2 into 5 is there, 2 into 5 is there. So it means if you can express the base number as 2 into 5, and if you have some other factors, does not matter, but in the factors of the base, 2 and 5 must be there. If 2 and 5 are not there, then the number will never end with the digit 0. Please do remember that. 4 to the power of n. 4 is nothing but 2 into 2 whole to the power of n. You have one 2, but there is no 5. That's why it will not end with the digit 0. And 6 to the power of n. That is 2 into 3 whole to the power of n. Again 2 is there, but where is 5? So that is why this number also never ends with the digit 0. So hope you understand, when the number ends with the digit 0, if base of the number ends with the digit 0, then only the entire number ends with the digit 0. When base of the number ends with the digit 0, if 2 and 5 are the factors of the base, then only the number ends with the digit 0. That is as simple as that. Now you see the number a into 5 whole to the power of n. If it is a into 5 whole to the power of n, then this a can be expressed as 2 into something. You can express whatever that something is. But a should have the factor 2. If a cannot be expressed as 2 into something, then p power n will never end with the digit 0. Please do remember that. Now coming to the problem. P power n is equal to p power n to end with the digit 0. A is equal to what? A is equal to what for natural number n? See here, a can be expressed as 2 into something. 2 into something means what? That number should be an even number, because every even number can be expressed as 2 into something. Any natural number, of course it is not every even number. Of course, this is what is the correct option. It cannot be an odd number because it is a into. Therefore, our answer is any even number. Right? Moving on to the next problem. See here, the next problem is, what will be the digit at units place of 9 to the power of n? So what is the unit digit of 9 to the power of n, or 9 to the power of n ends with which digits? I am going to put n is equal to 1 because n is a natural number. N is equal to 1. Then 9 to the power of 1 is going to be 9. And when you put n is equal to 2, then it is going to be 9 square equals to 81. When n is equal to 3, then it is going to be 9 cube. What is value of 9 cube? 9 ones are 9, 9 eights are 72. Once you observe here, and I would like to find for n is equal to 4 also. So 9 power 4 is nothing but this number multiplied by 9. 9 nines are 81, 1 8, 9 twos are 18 plus 8 equal to 26, 6 2, 9 sevens are 63 plus 2 is equal to 65. So and keeps going, right? See what are the units digit here. Here unit digit is 9, here 1, here is 9 again, means again here 9, again here 9. It means unit digit is equal to 9 when n is equal to 1, or n is equal to 3, or n is equal to 5, or n is equal to 7, or n is equal to 9, and so on. It means 9 power n ends with 9 power n ends with 9 when what is n? So when n is, what are these numbers? 1 3 5 7. It's an odd number when n is odd number. And 9 to the power of n ends with 1. See here, this is 1, and here also it is 1, and here also it is 1. For 1 it is n is equal to 2, or n is equal to 4, or n is equal to 6, and so on. It means for any even natural number. So 9 power n ends with 1 when n is an even number, right? So as simple as that. But 9 power n does not end with only one digit. It ends with 2 digits as per the value of n. Clear? But if you are asked 6 to the power of n ends with the digit what? 6 to the power of n ends with the digit 6 all the time, because 6 power 1 equal to 6, 6 square equal to 36, again ends with the digit 6, 6 cube equal to 216, again ends with the digit 6, and so on. Right? Next. What is the next problem? Which of these numbers always ends with the digit 6? ends with the digit 6. 44 to the power of n is there. Okay. So what is the units place of 44 to the power of n? That is only the units place of 4 to the power of n. Please do remember that. What is the units place of 44 to the power of n? That is only the units place of 4 to the power of n. Now 4 to the power of n ends with the digit. When n is equal to 1, then 4 power 1 is going to be 4. I think it's enough to say that it is not ending with the digit 6. Yes, first one is not the correct option. And coming to the second one. So what is the second one? That is b 2 to the power of n. So again, 2 to the power of n, when n is equal to 1, then it is going to be 2 power 1 is equal to 2. Not always. It may get for n value is equal to some number, but not all the time. Next c. What is that c? c is 6 to the power of n. Now put n is equal to 1, then it is going to be 6 power 1 equal to 6. When n is equal to 2, then it is going to be 6 square is equal to 36. See, you are getting 6. So it means 6 to the power of n always ends with the digit 6. Let us check one more number. What is that one more number? 8 to the power of n. So again, when n is equal to 1, it is going to be 8 power 1 is equal to 8, not ending with the digit 6. So 6 to the power of n always ends with the digit 6. Right? Next. Coming to the next problem. What would be the value of n for which n square minus 1 is divisible by 8? See here, n square minus 1 is exactly divisible by 8. It means remainder should be 0. So, for what value of n, whatever the quotient you get, for what value of n? See, n square minus 1. Okay, for what value of n is nothing but n should be a natural number. So n square minus 1 can be written as n minus 1 into n plus 1. Right? N minus 1 into n plus 1. For what value of n it is divisible by 8? It is divisible by 8. For example, if I take n is equal to 1, then it is going to be 1 square minus 1 is equal to 0. Is this 0 divisible by 8? Absolutely, because 0 divided by 8 is equal to 0. Right? When n is equal to 2, then it is going to be 2 square minus 1 is equal to, after 1 n is equal to 2, 2 square is equal to 4 minus 1 is equal to 3. 3 is not divisible by 8, right? Because 3 is smaller than 8. And when n is equal to 3, then it is going to be 3 square minus 1 equal to 9 minus 1 equal to 8 is divisible by 8. Are you able to identify the logic behind? When n is equal to 4, then it is going to be 4 square minus 1 is equal to 16 minus 1 equal to 15. Also not divisible by 8 because 16 is divisible by 8. When n is equal to 5, so it means 5 square minus 1, 5 square equal to 25 minus 1 equal to 24. Is this 24 divisible by 8? 8 3s are 24. Absolutely divisible. Once you observe, here for 0, 0 is also, it is divisible by 8. When you observe these things, for what value of n, n square minus 1 is divisible by 8. For n is equal to 1, it is divisible. For n is equal to 3, it is divisible. N equal to 5, it is divisible. What kind of numbers? N is equal to 1, 3, 5, 7, 9 and so on. They are all odd numbers. So, n square minus 1 is divisible by 8 for n is equal to odd number. Any odd number. N is any odd number, then it is divisible by 8. So, this is one way of answering the problem. But you can answer this problem systematically because we have two types of numbers. What are those two types of numbers? Even number, odd number. See, our number is, for example, capital N is equal to, the number is n square minus 1. See here, n is a natural number. It can be even number or odd number. I am taking n is equal to even number. So, what numbers are even numbers? A number which is the multiple of 2 is said to be even number. I am going to take 2k. Okay. Then n is equal to, in the place of n you write 2k. So 2k whole square minus 1. 2 square equal to 4 into k square is equal to 4k square minus 1. Do you know that 4k square minus 1 is divisible by 8? We cannot. So when n is odd number. So when n is odd number, what kind of numbers are odd numbers? 2k plus 1 or 2k minus 1 numbers are odd numbers. If you substitute, then n is going to be n square means 2k plus 1 whole square minus 1. So 2k plus 1 whole square is in the form of a plus b whole square. A square 2k whole square equal to 4k square plus 2ab. 2 into 2k into 1 equal to 4k plus b square. 1 square equal to 1 and minus 1 is also there. Minus 1 plus 1 cancel. From both the two numbers 4k square plus 4k, I am going to take 4k common. Remaining k plus 1. See 4 into k plus 1. What are these numbers k and k plus 1? They are two consecutive natural numbers. Product of two consecutive natural numbers always divisible by 2. You can take any two consecutive natural numbers and then multiply. In any two consecutive natural numbers, one should be even number, right? So that's why the product should be divisible by 2. So k into k plus 1 is divisible by 2. So it can be 2 into something. 2 into something into 4 is going to be 8 into something. It means when n is odd number, then n square minus 1 is divisible by 8. As simple as that. You can go by this way or you can go by this way, but result remains unchanged. So moving on to the next problem. The numbers 525 and 3000 are divisible by 3, 5, 15, 25 and 75 of course. So then what is the highest common factor of 525 and 3000? See, this is self-explanatory. 525 factors are 3, 5, 15, 25 and 75. They are the factors of that number. Of course, it may have more than those factors. Similarly, 3000 have these factors. So these are the common factors. These are the common factors for all these numbers. See, for example, I am taking 525 as well as 3000. Okay. So as he said, both the numbers are divisible by 3. Okay. I'm just giving you explanation. So here divisible by 3. So that 3 ones are 3. This is 22. 3 sevens are 21. 15, 3 5s are 15, and this is 3 ones and then 3 more zeros. Okay. Next, again divisible by 3. No, because 1 plus 7 is equal to 8. 8 plus 5 is equal to 13 is not divisible. So that is why it is not divisible. So that it is divisible by 5. And then you will get numbers. And again both the numbers are divisible by 15. And again both the numbers are divisible by 25. Right? Are this? Let us check. Okay, because we cannot write them all one by one. Okay, so if you once check them all, then whether it is divisible or not. So now when you divide by 5, what are you getting here? 5 3s are 15. 5 3s are 15. 25 is 5 5s are 25. And then 5 2s are 10 and then remaining 2 zeros. Got it? Both the numbers are again divisible by 5 if I am not wrong. Yes, both are divisible by 5. So 5 sevens are 35 and 5 fours are 20 and then 40. Once you observe, I don't think so that 7 and 40 are divisible by some other number, but they are not divisible. You see, 7 is a prime number. Of course, 40 cannot be expressed as 7 into something. See, from here onwards, there are no factors. There are no common factors. If there are no common factors, then product of these three numbers is only the HCF. So therefore, HCF of these two numbers is going to be 3 into 5 into 5. So what is 3 into 5 into 5? That is 75, because 5 5s are 25, 3s are 75. But this is what is the way of answering the problem. But if you once observe the given problem, 3 is the common factor, 5 is the common factor, 15 is the common factor, 25 is the common factor, 75 is also the common factor. And in the given problem itself, HCF, highest common factor. What is the highest factor of all these numbers? 75 is only the highest number. So without doing all these things, we can easily write what is the highest common factor. Hope you understand. Right. So moving on to the next problem. Find the least number which is divisible by all the numbers from 1 to 10. How do you know that it is the least number which is divisible by all the three numbers? For example, all the numbers. I have numbers 1, 2, 3, 4, 5. For example, I just want to find out a number which is divisible by all these 5 numbers. What is the number which is divisible by all the given numbers? That is nothing but their LCM, least common multiple of the numbers. So in order to find what is the least number which is divisible by all the numbers from 1 to 10, 1 to 10 is nothing but including both. So I am going to take the numbers from 1 to 10. Okay, so first number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because both are including. Again, you know L method, finding the LCM of the numbers. Okay, let us start from 2 onwards. Okay, 2, 1 is not, of course, 2, 1 is, neither a prime nor a composite number, and 2 ones are 2 is not divisible, 2 twos are 4, not divisible, 2 threes are 6, not divisible, 2 fours are 8, not divisible, 2 fives are 10. Got it? But still some numbers are divisible by 2. I am going with 2 again. So 2, here 1, 1, 3 cannot, 2 ones are 2, 5 cannot, 3 cannot, 7 cannot, 2 twos are 4, and then 9 cannot, as well as 5 cannot. Got it? Then I have one more 2 here, so that I am going to write that 2. Okay, because one more 2 is there. I would write again 1, 1, 3, 1, 5, 3, 7, but 2 ones are 2, and then 9, and then 5. Got it? After 2, what is the next number? Next number is 3. So some numbers are divisible by 3. I am going with 3 now. So 1 comma 1, 3 ones are 3, again 1, 5 is not divisible by 3, again 3 ones are 3, again 7, again 1, again 3 threes are 9, and then 5. Can you see one more 3 is there? I am going to take that 3 out. So 3 ones, 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 fives, ones, sevens, ones, ones, and fives. Okay. Now which number? Number is clearly appearing, that is 5. Okay. So 5. Here it is 1, 1, 1, 1. 5 ones are 5. Again 1, 7, 1, 1. 5 ones are 5. At last, you left with the number 7 here. So that 7 and you get only ones. So what is the LCM of numbers? Is the product. So therefore, LCM of these numbers is going to be 2 into 2 into 2. 2 twos are 4, 4 twos are 8. Okay, I am writing 8 into 3 into 3 is equal to 9. 9 fives are 45 into 1 more 7. Okay. So if you multiply all these 3 numbers, you will get a number that is what? Is the LCM of the given numbers. Right? Next. Moving on to the next problem. Here the next problem is going to be the sum of the exponents of the prime factors in the prime factorization of 196. Did you understand what is the problem? You take the number 196 and factorize this into prime factors. Let us do that. Okay. I'll go with the L method. That is what? 2 ones, 2 nines are 18, 1 6 16, 2 8s are 16. Again I go with 2 because this is prime factorization. Okay. Otherwise you can go with factor 3 also. We did already one problem. 2 4s are 8, 2 9s are 18. See again 49 is not divisible by 2 or 3 or 4 or 5 or 6 but 7. So 7s are 49. Therefore, you can write 196 as 2 into 2 is going to be 2 squared into 3, 7 into 7 is going to be 7 squared. This is what is the prime factorization of 196. Okay. So, the sum of the exponents of the prime factors. What are the exponents of the prime factors? Here exponent is 2 and here exponent is 2. So sum of the prime factors, that is going to be 2 plus 2 is going to be 4. So this is what is the one that you want. Okay. So sum of the exponents of the prime factors in the prime factorization of 196. So these are what are the problems given in previous board examinations for 1 mark. I think it is pretty much easier to score, to get 1 out of 1, whatever the number of questions given, but easily we can answer the problems given in real numbers for 1 mark. Hope you understand. And I think I'm pretty much happier that I'm sharing that very good information to you all to score good marks. Hope you understand. Enjoy the class. Thank you.